In this video, I am going to teach you how to use the local linearization techniques to find a square root of a number. Let's take that the 9 is a number. So if you want to find the square root of a number, so we know that the square root of a number is 9 is 3. So I want to find out the square root of a number 9.2. How do you find out without a calculator? This is a big question mark. You cannot find out so 9.2 without a calculator. It is quite difficult. So here comes the importance of linearization of the function. Let us take that this function f of x is the square root of x. Here x comes 9. So we know that f of 9 is 3. And similarly, if x equal to 9.2, so what is the answer? So f of 9.2, so we don't know. So now I am going to plot the variation of the square root of that function over the x. Here you can see that the function f of x is plotted over different range of x, but the thing is the given function is highly nonlinear in nature, so there is no way of finding the value of 9.2 in a very direct method. So here I am going to show you very simple techniques which you can apply for any systems, but considering the change of your present the variable to the next variable should be very, very small. And now I am zooming into the 9. If we zoom into the 9, you can see that the value of the 9 is exactly coming to the 3. Now I want to find out so what is the value of 9.2. If I again zoom in, you can see that. So here comes the value of 9.2. If you take the slope of this function, and you can see that if you take the slope of this function, you can see that the slope is exactly aligned with that this function within this small period. But if you zoom out, you can see that the slope is no longer is aligned with that function over a full range, but it exactly aligned for a small range. That means the function is completely, we can linearize. So this is just like a triangle. So now you can, it's just like a slope. It's a straight line, so with a slope. So now you can use that simple slope equation to find out what is that square root of 9.2. Now look at the figure. The above picture shows the complete the variation of the x over the range, and this is an f of x function, so that is square root of x. But here you come down, this is the enlarged version of this version, and you can see that the line AB is a straight line. That means that function is linearized for a small period. Now we can use the slope equations. So this is f of x, and let us take this as f of x plus delta x, and this is f of x. Sorry, this is x, and this is x plus delta x, and this is f of x, and this is f of x plus delta x. So slope is f of x plus delta x minus f of x. This the changing along the vertical axis and the change along the horizontal axis, all divided by x plus delta x minus x. So the slope becomes f of x plus delta x minus f of x divided by x plus delta x minus x is delta x. So we know that the slope is nothing but f dash of x. So from this, so the given values are f of x. We know that it is f of x is the square root of 9, and what is f of x plus delta x is the square root of 9.2. So this we need to find out. So this is the unknown. So rearrange the expression. F of x plus delta x is f dash of x into delta x plus f of x. So what is f dash of x? F of x is square root of x. If you take the differentiation of that function, it becomes 1 by 2 x power minus 1 by 2. So if you put all the values here, so what is x plus delta x is 9.2. What is f dash of x? F dash of 9 into delta x. Delta x is x plus delta x minus that x, that is 9.2 minus 9 plus f of 9. So what is f dash of 9? So substitute the value here, 1 by 2, 9 minus 1 by 2. So this becomes 1 by 6. So put the value here, 1 by 6 times the 0.2 plus f dash of 9 is 3. So the 0.2 divided by 6 is 0.033 plus 3. The final answer is 3.033. So the final answer of the square root of 9.2 is 3.033. Let us check this answer with the calculator. So the square root of 9 is 3. Now what is the square root of 9.2? Square root of 9.2 is 3.03315. So this answer is exactly matching with the calculation with the linear approximation method. So you can try this one, but provided the value of delta x should be very, very small, and you will get very accurate values. If the value of delta x increases further, you will not get a very approximate. So there are some changes that value never matches with the calculated value.